So we are going to solve Leetcode 2048. Next greater numerically balanced number. An integer x is numerically balanced if for every digit d in the number x, there are exactly d occurrences of that digit in x. So given n, we need to return the smallest numerically balanced number strictly greater than n. So what is being said is, let's say there is some number 1, then first of all we need to return a number that is greater than 1. So it should start with 2 or more, right? It should be greater than or equal to 2 or more, and it should be like smaller and numerically balanced. So it's equivalent to saying we need to return a number that is numerically balanced, and it comes first after the given number. And how we can determine a particular number is numerically balanced is basically, let's have a look at this 1333. Here in the digit 1 is occurring one time in my number 1, and my digit 3 is occurring 3 times. So that is being said also, that a number will be numerically balanced when the that digit is occurring equal to that digit number of times, right? So in 3 is occurring 3 times, 1 is occurring 1 time. So I think if we look at the constants here, it's 10 to the power 6. So basically 10 to the power 6, meaning like if I, let's say, take a 7-digit balanced number, then that will be my maximum number that is possible. Like, just after 10 to the power 6, that number is going to come, and that will be my max possible value. And if I and the, I can basically just iterate, like I am given n, right? I can like start from n plus 1 and go up to this last balanced num, and for every number I can check if it's a balanced number or not, and the first number which I encounter I can return directly. So let's do it that way only. Let's say the int is -1, just to return it, or basically we will be returning in the inside our loop only. For int I is equals to n plus 1, so I will start from n plus 1, and now the largest number, that is the balanced one. So 1 is occurring 1 times, 2 is occurring 2 times, and 3 is occurring 3 times, 4 is occurring 4 times. Now what this means is, so 1 is a balanced number, 2 and 2 is a balanced number. I can now combine them. So 1 2 2, 1 2 1 2, and 2 2 1, they are also balanced, right? 2 is occurring 2 times, 1 is occurring 1 time. Then I can have 3 3 3, so 3 is occurring 3 times, that is also a balanced number. So I can sort of like create numbers this way as well. So this will be 5-digit number, and then 5 occurring 5 times. This will be 6-digit number, and 6 again. So basically, for one I can go through like 2 3 4 5, create all the required numbers. This will be a finite sort of numbers only. We can either like hard code these values, that will be another solution. So I can like create this by hard coding, or manually calculating all the balanced numbers, and then I can do sort of a binary search wherein I need to find the first number that is strictly greater. So basically I can do a simple binary search. Let's say I have the number 23, I can do the binary search and it will return me 122, because these numbers are sorted, right? uh, the largest number that is possible here, because it's given that our constraint is 10 to the power 6. So 1 2 3 4 5 and 6, Now the largest number, so 1 is occurring one time. Now I have 6 digits. I can uh, basically fill them up with these numbers. 1 I can't take because I have already taken. 2, let's take 2. 2 I will take 2 times. If I take 3 now, 3 I will have to take 3 times. Then I will only have 1 digit left and I can only take 1. uh, Basically if I take a 4 after this, like I will have to take 4 fours, but that will be a lot bigger number. Rather let's try it with 4. If I take 4 fours, well this is like a number, sort of number which will be just greater than my upper bound, basically whatever is the maximum value that is possible in the input in the end. So I will just traverse to this number and I should find a balanced number till then. So I will just go till this number. I will do I plus plus. I will find a number like before that only, but it's just a upper bound is balanced. If the number is balanced, I will the first number I get, I will just return that number. And here I can do the return -1 just to actually compile it. And here I will now create, so this can return me a boolean is balanced. Therein I will pass some number n, let's check it n. And what I will do is, so in the n we just saw, right, we can have a maximum of 7 digits, right? Or rather the numbers will be like 0 to 9. So I can just directly take an array wherein I will take, let's say, digits array, and the size of it will be 10, so 0 to 9. In any base 10 system I can have those many digits only, right? Now I can just simply do how we go through every digit is basically I will say that digits of n modulo 10. So basically that's the last sort of digit, right? So this is the digit 3. Let's say I'm taking it 333. I do a modulo by 10, I get a 3 digits, so I will increment the count of 3 by 1 and divide it by 10. So basically now I have now number 33, right? And I can do and divide equals 10. So this will fill my digits map. Now I can go from 1 all the way to the 10, less than 10, I plus plus, and I will check if this digit is occurring more than 0 number of times, and the digits at I. So if this digit is, so basically this digit is occurring digits I number of times, and if it is not equal to I, that then it means the current number is not balanced, right? Otherwise it will be a balanced number. Let's see. Okay, start 0 only. I will just start with 0 only. Wait, let's try to submit this. It works.